Hello. So we are looking at this question today. It says the wave pattern produced by the siren of a train is given below. This is the pattern. The train driver detects the frequency of 608 Hz. Okay. Question says that Jane says the train is in motion. Give a reason to support Jane's statement. So when you look at this pattern, what do you see? What we see is non-uniformity of the pattern. Towards Y, we see what we call compression. The wave fronts are close together, creating shorter wavelength, leading to higher frequency. While towards X, we are looking at wave fronts which are very much spaced, leading to longer wavelength. So that's what we have. And when you have a non-uniform wave pattern, the conclusion is that the object under consideration is in motion. So that is it. The supporting evidence is coming from non-uniformity of the wave pattern, where on one side we are seeing shorter wavelength leading to higher frequency, and on the other side we see longer wavelength implying lower frequency. So that is it. So then comes the next question. It says, state the direction of motion of the train you pick from towards Y or towards X, and give a reason for your answer. So when you analyze this wave pattern, we can assess where the train is moving towards. Okay, what do we see towards Y? The wavefronts are closer, the wavelengths are shorter, and the frequency is higher. Well, towards X, the wavefronts are sparse. And what do we see towards X? The wavefronts are sparse, wavelength is longer, and frequency lower. So from here, what do we assess? Our assessment is that the train is moving towards Y. Reason being that it is towards Y where we experience higher frequency. Yeah, so that is that. So this question says that the listener at Y detects a frequency of 792 Hz. The speed of sounding is given 340 meters per second. Calculate the velocity of the train. And how do you go about this? Okay, let us start with what we have. Okay, what we have the frequency of the source, which is 680 Hz. Okay, how does it become the frequency of the source? We know that this is the frequency detected by the driver of the train, and the driver of the train is inside the train. So if he's inside the train, there is no relative motion between the driver and the train, so there's no Doppler effect. So the driver experiences the same frequency as the source. Okay, what else do we know? We know that the listener at Y is not moving. And we are looking for velocity of the train, which is the source. But we know something else. We know frequency hertz, which is 792 hertz. So that is what we have. And we are given velocity of sound in air. So under this circumstance, what do we do? We equate our formula. It says frequency hertz is V plus or minus VL over V plus or minus Vs, all this one into Fs. After putting the equation, then you have to assess the situation, whether it's approach or away. And what we are seeing is that the train is moving towards Y, so it is approach. And if it's approach, this equation can change to become frequency hertz equals to V plus VL over V minus Vs, all this one into Fs. So after getting this, then what do? We substitute. And in substituting, this is what we know. We know frequency hertz, which is 792. Okay, we know velocity of the sound in air, which is 340. And it's a plus. And a plus 0, because we know the velocity of the listener. All this one is going to be 340. It's minus Vs, which we are calculating. All this one into the frequency of the source, which is 680. So when you try to simplify this, what do we get? You are going to get 792 over 680, giving you 340 over 340 minus Vs. So what you get out of this is 1.1647, which is going to be equal to 340 over 340 minus Vs. So in simplifying this, or we can do it through cross multiplication, and we get 340, which is equal to so when you get here, what do? We correct like terms, and you have 1.1647 Vs, giving you 396 minus 340. And what do you get here? 1.1647 Vs, giving you 56. So that is it. We have our answer as 48.08 meters per second. That is the velocity at which the train is moving. So we come to this question. It says that calculate the frequency detected by the listener At X, the listener here, what frequency will that listener detect? So what do we have here? We are looking for FL at X. We don't know it, but we know something. We know frequency of the source, which is 680 Hz. We know velocity of the listener. The listener is stationary, so it's 0. But we know velocity of the source. We calculated it as 48.08 meters per second. And we know velocity of sound, which is 340 meters per second. So with this information, what do? We quote the formula. It says that FL is equal to V plus or minus VL over V plus or minus Vs. All this one into frequency of the source. After having the formula, then you assess the situation. Is it approach or away? We know the train is moving towards Y. So for example, at X, the train is moving away. So having that one, what do? We change the equation to suit this situation. So for away, we are going to have FL equals to V minus VL over V plus Vs, all this one into Fs. With this, what do? We substitute. So we are going to have FL equals to V, which is 340, minus VL, which is 0, over 340, plus Vs, which is 48.08. All this one into frequency of the source, which is 680. So next is to simplify. In simplifying, we are going to have 340 over 388.08. This one into 680, giving you, we have it as 595.75 Hz. Then comes this question. It says that which listener, X or Y, will experience longer wavelength? Okay. To answer this question, what do? You have to remember something, that listener Y is experiencing higher frequency because the source is moving towards the person here. But you have to know that frequency and wavelength are inversely proportional. So higher frequency implies a shorter wavelength. But the question says, which listener will experience a longer wavelength? Let's go to X. X experiences lower frequency, and lower frequency means longer wavelength. So the answer for this question is X. And with that, I'd like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Don't forget to subscribe, to comment, to like, to share. And I need also to remind you that PSSB is a channel which deals with physical sciences, grade 12, 11, and 10. and in natural sciences, grade 8 and 9. We advise you to make use of our playlist. It is well clear. It will help you to look for the material which are of interest to you. So make use of it. Just go to playlist and look for your grade. With that, I'd like to say bye-bye. See you next time.